And we are live, doing it from the PC this time. How do you like that? Please bear with us, folks. We're going to get things started in just a moment here. In the meantime, play some music for you. Just play Unified Theory for you here if I can find it. Just play Unified Theory for you here if I can find it. Just play Unified Theory for you here if I can find it. All right. Anyway, everybody, welcome. Welcome to yet another Space Weather live stream. All right. Anyway, everybody, I got the music way too loud. Welcome to yet another Space Weather live stream. I got the music way too loud. Welcome to yet another Space Weather live stream. Oh, geez, the audio is horrific. I can hear it. Oh, man. Oh, geez, the audio is horrific. I can hear it. Oh, man. Oh, geez, the audio is horrific. I can hear it. All right, we'll cut the music out. Oh, man. All right, we'll cut the music out. There we go. All right. We figured it out. We had a second microphone turned on. There we go. All right. We figured it out. We had a second microphone turned on. There we go. All right. We figured it out. We had a second microphone turned on. I apologize if you're hearing any echo. Geez, my voice sounds shattered. What a mess. All right. At least we got this to screen share here, and the audio sounds pretty decent. So let's look at 193 angstroms. You see some diffuse coronal holes there. Actually, one looks like it filled in recently. And let's look at a different view here. 171 angstroms. I got to keep track of my tabs here using the cell phone because I don't have all the same tabs open on the computer. But hey, look on the bright side. At least things are improving. We've got actual screen capture going on. So yeah. Anyway, there's the view in 171 angstroms. See this active region here? And something noteworthy is up in this area, we have a perpendicular polarity sunspot, although I think the umbra is now gone. And down here, this is actually a reverse polarity active region also. Let me just show you what I'm talking about here on the magnetogram. Look at the high-res version of it here. Now, as our regular viewers are probably aware, usually sunspots form in an orientation like this, where the one polarity leads the other one. Now, normally when we see them south of the equator, we're going to see these with a green leading charge from the North Pole, a negative charge leading. And anyway, this spot up here is 90 degree, it's turned 90 degrees to the way we normally see these active regions. So it's another indication of cycle 25. So that's a interesting little tidbit. And it is talked about also on spaceweather.com. There's that sunspot we're talking about. So you see here, you've got a normal polarity sunspot. Here you've got a reverse active region, plage, normal polarity plage, with the yellow charge leading and the green charge following. Here you see below the equator, which makes this reverse polarity. Normally when you see these below the equator, these would be opposite. And then you see this, which is the weirdest of all. Now, when they took this image, there was some umbra, as you can see there. There was actually some umbra on there. I think that has since evaporated, but that is an odd field. And, you know, the first time we saw any reverse polarity stuff was all the way back in December of 2016. So moving on to, got to have this in the right order. All right, the real-time solar wind we'll look at next. It would be perfect if it would load. There we go. And there's a real-time solar wind. No consistent coronal hole connection there associated with the phi angle. Solar wind density has just dropped way down to 0.56 protons per cubic centimeter, and the solar wind speed is diminishing also. No real surprise there. Let's go from there to the Space Weather Enthusiast dashboard. And we want to look at the Enlil prediction here, as we typically do. Basically to show you that it's incorrect. Yeah. So there's the Enlil prediction. You see that dip in the plasma density is kind of predicted there. We're expecting very low density levels, but they're still predicting a increased velocity there. So just figured I'd show you that. Next, let's look at the Gong 2. We'll just do the regular top view ecliptic plane field plot here. There's the data on that. Keep in mind it's an hour and 8 minutes old. Okay. I don't know why it's playing so slow. Let's refresh that. That is weird. All right, well, let's just look at the last frame instead. Anyway, it looks like magnetic smooth sailing here. You don't see any big undulations, although this active region here does have some potential. Next, let's move on to spaceweathernews.com. Look at the rest of the data here. Tiny little bit of X-ray activity there, but nothing to really shake a stick at. Magnetometer data still looks completely 100% jacked up. I mean, I don't believe it. Do you? Ben Davidson doesn't believe it. Something is going on with the Ghost 15. Let's hope it isn't permanently damaged. Maybe it just needs calibration. We can hope. KP index has risen back up to 3. There's the electron flux. We see charging hazards around south of the equator there. And we even see some surface charging there around Central America. And the F2 layer is actually very charged right now. And we see a large disparity in here. So that's looking a little charged than it has been previous days, folks. And so the charge disparity will be larger when this reaches South America. Although without any coronal hole magnetic connections, that's not really a significant uptick in the earthquake risk. Next, let's look at the magnetosphere movies here. First, the velocity. And we're going to see this associated with very low density. So don't be surprised if this looks kind of weird. There's a velocity view. We do see a low velocity zone there associated with dawn in the south near the magnetotail. Here's the density, which is going to look shockingly low, especially with that recent pulse with the solar winds so low. So you'll see this appear to puff out. Keep in mind it's actually density down. Low density, not high density, as low density is the white. You see a very low solar wind come in there in the most recent bit, I would assume. And there's the extremely low velocity solar wind coming in. I mean, low density, rather. And here's the pressure. And you'll see this drop down very low at the end. Although there is much higher pressure right now in the bow shock than there was yesterday. So this is something to keep an eye on, as this will continue to descend for a little while here. So that's, anyway, there's your magnetosphere movies. Let's look at geospace ground perturbations. Now, later I'm going to set this all up so we have all the tabs. We don't like to have any wasted time here, so that everybody can use this channel as a resource to get all this data. Anyway, here's the magnetic perturbations over the poles. This is a luxury for me too, by the way, folks, because I'm able to look at this on a computer screen instead of on a small cell phone. Part of the reason why we make the videos is so we can watch them on a bigger screen and show them to other people on bigger screens where all the data is more clear. We see a bit of undulation going on there in both poles. Here's the view from a global perspective. All right, and let's see what we've got next here. Next on the docket is volcanoes. Go ahead to volcanodiscovery.com. Great site, by the way. And click on volcanoes today. Here's your volcano rundown. So Karimsky, we've got explosive activity going on there, producing a 10,000-foot ash plume. Shivaluch, activity remains elevated with no significant changes, producing viscous lava. Mount Manam, explosive activity continuing there also, 10,000-foot ash plume. So it looks like a volcanic uptick a bit here. Continuous emissions with a 10,000-foot ash plume at Ducono. Popocatépetl, possible emissions. Fuego, ongoing emissions. Revenador with a 14,000-foot ash plume. Sabancaya, low-level gas and possible ash. And Planchon Petaroa with a 14,000-foot ash plume there. So a little volcanic uptick, folks. Now we're going to head to the U.S. downgrade service. Bear with me, I've never used this on the computer before, so let's get a different view here. Make it look a little bit more aesthetically pleasing. Okay. So we're only looking at 4+ magnitudes here. First, we've got this 4.2 near Acapulco. Let me zoom out so it just gives us a little blue image of where they're located, the earthquakes. All right. So we're going back 24 hours here, folks. There's one in Papua New Guinea, a 4.6. Here's a 4.6 in Russia. 4.4 in Papua New Guinea. There's the one near Acapulco. Another one at Papua New Guinea. We got a 3.3 near Old Faithful, Yellowstone. And I think the weirdest of all, a 4.5 in Dove Creek, Colorado. Hey, Oppenheimer Ranch project. Did you feel that one? I don't know how close it was. Anyway, we also see a 4.8 in Indonesia, 4.5 in China, another 4.4 in Indonesia. Here's one in between Svalbard and Iceland at a 4.5 magnitude. And looks like the most recent one was way out to the west Indonesia there. So there's your earthquake rundown. We're still showing a pretty significant drought in magnitude 6 and 7 earthquakes. So if you're in an earthquake-prone region, please be on alert. These areas around here, north and east of Australia, including Japan and the Philippines, as well as Western, South, and Central America. Been seeing deep quakes there. So those areas remain on alert. We're going to skip the Galaxy Zoo segment today, and let's head to space.com. You can see an article to cover there, and it's a good one. Solar wind leaves, quote, sunburn scars, end quote, on the moon. Now, regular viewers probably well aware of this. The catastrophe cycle, the fact that the sun goes into a nova state and blasts a bunch of glass out into the solar system. We think it's associated with things like the Younger Dryas event. Appears to be on some sort of 12 or 14,000 year cycle. What's good about the article is that, well, let's play this and see what this is all about. I'm going to take a chance and play the audio for a minute.
Even the moon has the scars to prove it. New NASA research suggests that some of the coloration we see on the moon could actually be a form of sunburn.
Okay, so that's it's a step in the right direction. But what's really good is this. What they're saying is that these scars on the lunar surface are electrical scars. You see that? Now, as you read the article, it gets a little weird at the end. But it's right on the homepage of space.com if you want to check it out. They're actually affirming that these are caused by electrical discharge. So that sounds like a step in the right direction. The implication is that small magnetized areas of rock near the surface cause localized fields. Now, this is what would happen if the Earth lost its magnetic field. There would still be pockets of magnetism that would remain in place. So, in any case, I like it because they're actually talking about acceleration, reconnection, turbulence, and electrodynamics of the moon's interaction with the sun, which is what's really going on. So check out this great article, space.com. Next, let's go to Cosmos Magazine. I think that's the right URL. Because there's an article here too. They're also covering the sunburnt moon, but let me see here. Oh, here we go. Just wanted to take a moment to bloviate about what I think of autonomous vehicles. Now, yes, Regular viewers are aware that I spend a lot of time driving. However, my main job isn't driving. My main job is applied science in the field. Essentially, it's a chain of custody role, but it also includes all aspects of field administration. So, what's the point? The point is that I don't like autonomous vehicles. I think autonomous vehicles are a stupid idea and that they're way off. Now, yes, once it's good enough that it's safe, it's safe. But you ever tried using the software on your smartphone? You notice how it rarely works correctly? I mean, Google is a horrible, horrible software manufacturer. There's no doubt about it. I started writing code when I was about 4 years old, before entering school, even kindergarten. I was writing code before that in BASIC. And when we wrote code in the 80s and 90s, we did things like debug the code. And it just doesn't happen now. You know, you need 3 pieces of redundant software to do 2 activities on most of your Google accounts. So anyway, the point is, I don't trust them to write software to have cars driving around on the roads. I just don't trust them. I think it's a stupid idea. Now, yes, it'll be more efficient once all the systems are in place and once they're safe and once they work well. Yes, it will be more efficient. I've been calling for the breakdown of the internal combustion engine since the 1980s. I'm not in the pocket of oil companies, folks. I realized when I was in junior high that internal combustion engines are wasting about 20% of the energy put into them. We already had engines that were over 90% efficient in the 1980s. So, all right, but I digress. It's an article about how autonomous vehicles can be hacked, and that doesn't sound particularly delightful to me. Let's move on to phys.org, where we found some articles there that you may find interesting also. First one is about adaptive radiation. Well, what does that mean? Well, it turns out, and we're not talking about radiation, we're talking about the radiation of traits. Anyway, the study's super interesting, and it found that colored lice living on colored pigeons are able to change their color phasing and pass it on to future generations after only 4 years. What does that mean for you? That means that you will evolve much more quickly than you may think you will. I mean, 4 years is a snap of the fingers in terms of evolutionary biology. The point is that if you're a louse on a white colored pigeon, you want to be a white colored louse. And if you're on a black colored pigeon, you want to be black. And anyway, it's an interesting article. Read through it. It's a big deal. And people have been trying to bridge the micro and macro evolution for a long time, says Dale Clayton, professor in biology at the U and co-author of the paper. This study actually does it. That's a big deal. We'll leave links in the description after we're done streaming. Now, let's see if I can find this. To make it easy. Oh yeah, I found it right away. Nice. All right, so here's the page that we usually use to refer to our cosmic ray monitors. Just wanted to do a rundown of that real quick. Here's first, we got Athens. So there's a situation at Athens, neutron monitor there. Next, we'll look at Mexico City. There's a situation at Mexico City. By the way, this one allows you to look at different time periods, for instance. You know, there's a 10-year chart Oh, I need a 1 hour data. There we go. There you go. And you see at Mexico City, this was actually the cosmic ray peak there. Anyway, moving on to Moscow. There's the Moscow monitor. Not returning data for a solid week. What's going on, Russia? Get your weight up on your neutron monitor. And lastly, here's Oulu, Finland. Here's DOMC Antarctica. And there's DOMB Antarctica. For those non-regular viewers out there, the reason we look at cosmic rays is because cosmic rays are associated with increased cloud nucleation, solar minimum. Cosmic rays create additional ionization paths in the atmosphere, and clouds form on those ionization paths. And when low clouds form, especially such as stratocumulus, they increase the Earth's albedo, reflecting more sunlight back into space, which makes the planet cooler. It's a positive feedback mechanism associated with solar minimum. Now, let's go back to phys.org for a minute here. Because we got another article about astronomy. Yes, okay, use cookies. We don't mind. Now, this is a super interesting one about large cycles. We're talking about 200 million year old cycles, 400 million year cycles. Suggestions that the solar system has been totally different than it is today. So another super interesting article. We're not going to go over it too in depth here, but apparently there's a 405,000 year cycle over the last 200 million years. And yeah, so this is the kind of stuff that studying geology leads to. And yeah, interesting stuff. So this may lead to a greater understanding of the catastrophe cycle, things like the KT boundary that we see in the geologic record. And what else do we have? We got nothing. All right, so let's look at the intensity gram here and see if we see any umbra associated with those regions. I think those are only penumbra, folks. Doesn't really look dark. Nope, those aren't sunspots, but yeah. Interesting active region, especially with that perpendicular polarity thing, that we could actually be watching the shifting of the cycles before our very eyes here. Let's just take a look at it in 94 angstroms while I thank our viewers for tuning in. We apologize for the audio difficulties at the beginning. At least we figured out what it was, having two mics turned on at the same time. And here's the 94 angstroms view. Those of you not familiar, the reason we look at 94 angstroms is because it takes 5 times as many photos. So it gives us a little bit more insight into things like solar flares. We're going to probably make a second video today. We just want to brush up our ability to live stream and to produce videos as well. This does give us a little extra time to be able to do more things. The live streaming, it's a great benefit. So we're going to try to keep it as content rich as we can get it. Oh, we do have a couple other things here. A couple other things. Now, we'd like to refer you to nextdoor.com. We have a lot of preppers that watch our channel. And so check out nextdoor.com. What's the point? Is it because you want to meet this lady that looks like Nancy Pelosi pushing a bicycle through the park? Well, probably not. What it is for is to allow you to network your neighborhood together. This organization will actually send out postcards to other people in your neighborhood so that you can create a digital network where you can get in contact with people. Now, when I looked this up, my neighborhood actually did not have one of these. There were a couple local ones that were not connected to where I live, so I actually created one myself. So I'm the administrator on this, and it allows, we got about, I think we have about 50, we have a little over half of the houses in our neighborhood. You're typically going to want a thing like about a 2-mile area, and you know, you can set it up however you want. You can set it up so you get email alerts, text alerts, and you know, for people that don't even have the internet, this company will actually send postcards to their residents and ask them if they want to join and so on. It's a great way to meet your neighbors. Maybe not tell them you're a prepper if you're a prepper, because you may not want them to know that, but at least you'll have the ability to help out where you like, and you know, help the local infrastructure. Now, there's one other unfortunate thing that we've got to cover. Has nothing to do with space weather, really, except that everybody is in space. The video that we watched last night on YouTube, and I guess I can't spell. So, what's the video about? Unfortunately, it is about Rush.
So are you at peace? Are you comfortable and you were at peace with the way Rush ended? I mean,
so we'll leave links to this also. Sadly, Rush is no longer a band. And it has to do with Neil Peart being a perfectionist and the physical limitations of being a drummer. It's very physically taxing to be a drummer. And so taking the opposite route of Kiss, who has been doing farewell tours since the late 80s, Rush is done. So it's a sad thing. One of the best bands of all time. And for that, we thank you, Rush. So let's close things out at 304 angstroms, because there's a lot of things to do today. By the way, we do see some filaments there in the northeast. And we do see our operation increasing in quality. Yes, I know the audio at the beginning of this stream was pretty bad, but onward and upward, people. It'll never be now again. Also, you can find all the links to our other social media pages on smAshomash.com, a domain we just bought less than a week ago. In any case, thanks for tuning in, folks. Remember, when you're looking at odd polarity of sunspots, don't drink. And if you drink, look at odd polarity of sunspots. Just don't drive.